All right, welcome. Today we are cracking a really interesting code. We're talking about behavioral design patterns. Now, that might sound a little technical, but think of it as the secret language, the hidden rule book that stops complex software from just, well, falling apart. I mean, have you ever stopped to think about it? Why isn't all software just a tangled, buggy mess? Seriously. Every time a developer adds a new feature or a new option, things get more and more complex. So, how do they actually fight back against that? That inevitable chaos and keep everything running the way it's supposed to? Well, the answer, it turns out, is pretty elegant. It's something called behavioral design patterns. These are basically proven, reusable solutions. Think of them like blueprints from a master craftsperson. It's a whole toolkit for building software that's not just powerful, but also flexible. So let's go ahead and open up that toolkit, shall we? Let's check out the first set of tools. Okay, section 1, changing an object's guts. Yeah, sounds a little dramatic, but it's exactly what these first patterns do. They're all about making an object's core behavior, its guts, totally flexible and interchangeable. So here's the puzzle we're trying to solve. How do you let an object change what it does without having to completely rewrite it? Think about, say, a GPS app. First, you have driving directions. Then you add walking. Then public transit. If you just keep cramming if this, then that logic into your code, it becomes this monster, a huge, bloated beast that's impossible to maintain. So how do you do this the smart way? The answer is something called the strategy pattern. It's a brilliant idea. Instead of having one giant object that tries to do everything, you pull out each of those different ways of doing things, the algorithms for driving, walking, cycling, and you put each one into its own separate little container, its own class. Then your main app can just grab and use whichever strategy it needs at that exact moment. It's super flexible. And this quote just nails the concept, right? Imagine that you have to get to the airport. You can catch a bus, order a cab, or get on your bicycle. See? These are all just different strategies to achieve the same goal. Your destination, the airport, is fixed. But how you get there can change depending on traffic, or money, or how much you feel like exercising. The app is doing the exact same thing, just with code. So, strategy isn't the only game in town. It's got a couple of cousins, state and template method. Now, strategy and state are pretty similar. They both use this idea called composition. Basically, an object has a behavior. The big difference is what they change. Strategy lets you change the guts, how an object does something. State, on the other hand, changes the object's behavior when its state changes. Think of your phone going from unlocked to locked. Its behavior changes because its state changed. Then you've got template method, which is totally different. It uses inheritance. An object is a type of algorithm, and it just lets you tweak a few specific steps in a process that's otherwise fixed. All right, let's move on. Section 2, untangling object conversations. This next set of tools is all about one thing, communication. Specifically, how to keep all the different parts of your software from getting into a chaotic, tangled conversation. Because here's the problem. As an app gets bigger and more complex, you can end up with this web of dependencies. Every object is talking directly to every other object. We call this spaghetti code, and it's a total nightmare. You change one tiny thing over here, and suddenly 10 other things break over there. It's a domino effect of disaster. So how do you fix that? Well, you introduce a mediator. The mediator pattern is all about restricting that direct communication. Instead of every object shouting at every other object, they all have to talk to one central hub, the mediator. It acts like a traffic cop or an old-school switchboard operator, making sure every message gets routed to exactly where it needs to go and nowhere else. And this analogy is just perfect. Think about pilots. They don't just chat with each other to figure out who lands first, right? That would be absolute chaos. Instead, they all talk to one person, the air traffic controller. That controller is the mediator, coordinating everything to keep the skies safe and orderly. Software can work the exact same way. Now, besides the mediator, there are a couple of other really important communication patterns. You've got the observer, which is basically like a magazine subscription. One object, the publisher, has some news, and it notifies all of its subscribers automatically. Then there's the chain of responsibility. This one is exactly like escalating a tech support call. You have a problem, you ask the first person,
If they can't help, they pass you up the chain to the next person, and so on, until someone can finally solve your issue.
Okay, on to our third and final category, and this is where things get, I think, really, really cool. Section 3, making actions and structures tangible. These patterns are all about taking abstract ideas, things like an action or a saved state, and turning them into actual physical objects that your code can hold onto, pass around, and work with. So here's the challenge. How do you build something we all take for granted, like an undo button? Control Z or Command Z. Or how do you add a new feature, say export to PDF, to a whole bunch of different things in your app, without having to go back and change the code for every single one of them? It takes a pretty clever way of thinking. A huge part of the answer is the command pattern. What this does is it turns a request, like delete this paragraph or make this text bold, into a self-contained object. It's like a little package that holds all the information about that request. The classic analogy is a waiter taking your order. They write it down on a ticket. That ticket is the command. You can pass it to the kitchen, you can put it on a queue, you can even cancel it. And the perfect partner for the command pattern is the memento pattern. A memento is exactly what it sounds like. It's a saved state, a snapshot in time. An object can basically take a picture of itself, create a memento, and then give that to someone else to hold on to. But here's the key. Only the original object knows how to use that memento to turn back the clock and restore its old state. So here's how you put them together to get that magical undo feature. It's a 5-step dance. 1. Your command object, let's say make text italic, is about to run. 2. Before it does anything, it asks the main text editor, hey, give me a memento of your current state. 3. The command runs and changes the text. 4. Now the user hits undo. What happens? The command object just takes that memento it was holding and hands it back to the editor. And 5. The editor uses that memento to restore itself to exactly how it was before. It's so elegant. 2 more quick ones in this category: iterator and visitor. Think of an iterator as your own personal tour guide for a collection of data. It knows how to walk you through everything in the right order without you needing to know how the city is laid out. Then you have the visitor. This one's like an insurance agent who needs to visit a bunch of different kinds of businesses, a factory, an office, a shop. The agent brings their own operation, calculating risk, to each place without changing the businesses themselves. Okay. So we've looked at a bunch of individual tools, but let's zoom out for a second. Section 4, why does any of this matter? What's the big unifying idea that connects all of these patterns? If you remember one thing from all of this, let it be this master principle. Separate the parts of a program that change from those that stay the same. That's it. That's the whole game. Every single pattern we've talked about, in one way or another, is just a clever way to do exactly that. Find the stuff that's going to change and wall it off from the stuff that needs to stay stable. That is the secret to building software that can evolve and last. And when you do that, the benefits are just huge. Your code becomes way easier to manage because you've reduced all those tangled connections. It's way more flexible. You can add new features without risking breaking everything. That's the open/closed principle in action. But maybe the biggest benefit is that it creates a shared language. A team of developers can just say, let's use a mediator for this, or this needs a strategy pattern, and everyone instantly knows exactly what the plan is. It's incredibly powerful. So here's a final thought for you. You've now seen the patterns that software is built on. So I ask you, what hidden patterns are running your digital life right at this very moment? The next time you hit undo or get a notification or use an app that just works seamlessly, maybe you'll see it a little differently. You're not just a user anymore. You can see the invisible architecture, the elegant patterns running just beneath the surface.